In this video, we will have an intro to stoichiometry, or the calculations that we use to determine amounts of substances. Atoms and molecules are very small, and we must be able to count them in a reasonable way. In the lab, however, we don't measure out molecules and atoms. We measure out a certain amount of grams of solids or milliliters of liquid reactants. And then we measure the same amounts of the products at the end of a reaction. In order to relate the measured amounts to the number of atoms, molecules, ions, or formula units, we need a conversion factor. Avogadro's number is the conversion factor that we use. Avogadro's number is simply a number. It's just a number. Just like a dozen is 12, or a pair is 2, or a ream is 500, a mole is 6.02 times 10 to the 23 particles. So particles can be anything: atoms, molecules, ions, formula units. If you want to get creative, people, insects, it doesn't matter. If you have 6.02 times 10 to the 23 of those items, you have 1 mole. And we can use that mole as a conversion factor, as we see here. As we see here, where we can say 1 mole per 6.02 times 10 to the 23 particles, or 6.02 times 10 to the 23 particles per 1 mole in a fraction. However, in order to do these types of calculations, we need an additional set of conversion factors in order to relate the measured amounts in grams to the number of moles of a substance, and to compare the amounts of reactants to products. So what are those conversion factors? Well, before we can do any type of calculation, we have to know how much of a substance we have. And the way for us to do that is we can use the molar mass to help us determine how much of a substance we have. And it's actually just the sum of the masses of each atom in a chemical formula. We use the units grams per mole. When you look at the periodic table, the masses are given in atomic mass units. Numerically, it's the exact same thing as what we use to determine molar mass in grams per mole. So for example, if we wanted to do the molar mass of water, we have the molar mass is one of those conversions that we need to help us do these types of calculations. And the molar mass is simply the sum of all the masses of each atom in a chemical formula, and it's given in grams per mole. When you look at the periodic table, the masses of the elements that you see are in atomic mass units. Numerically, this is exactly the same as the molar mass of those elements. So we can use those numbers and just use the grams per mole unit. So if we wanted to take a look at the molar mass of water, we see that we have 2 atoms of hydrogen, each being 1.10 grams per mole. We have 1 atom of oxygen, each being 16.00 grams per mole, for a total mass for the entire molecule of 18.02 grams per mole. In addition to the molar mass, a lot of times we need to have a mole-to-mole ratio when we are doing these conversions. And we can have 2 different mole-to-mole ratios. One type of mole-to-mole ratio is going to be based on a chemical formula. So looking at water, the chemical formula of water, water is composed of, if we have 1 mole, 6.02 times 10 to the 23 molecules of water, well, that whole giant lot of molecules of water has a total of 2 moles of hydrogen atoms and 1 mole of oxygen atoms, simply from the formula. Okay? So we can compare the number of atoms in a formula, or the number of ions in a formula, to the whole entire formula using a mole-to-mole ratio. Another type of mole-to-mole ratio we will use often is a balanced equation. given the balanced equation of the synthesis of water, where we have 2 moles of hydrogen reacting with 1 mole of water to produce 2 moles, with 1 mole to oxygen, and it reacts to form 2 moles of water. So this balanced equation, those coefficients, give us the number of moles. These coefficients give us the number of moles of molecules or formula units that have to be, or that are produced during a chemical reaction, all because of the conservation of mass. Let's take a moment and do some molar mass practice so we can figure out how to calculate the molar mass. Given the formula of iron to phosphate, we can calculate the molar mass. Now, I will give you the numbers that I've obtained from the periodic table, but when you are doing these stoichiometry problems, you must have a periodic table present so that you can calculate molar masses for your substances, because you're always going to have to calculate your molar mass generally before you begin solving the problem. Right? So you got to do one step before you can even solve the problem. You've got to calculate the molar mass. All right, so for iron 2-phosphate, we have, for iron, we have 3 atoms of iron in this formula, and each has a mass of 55.85, and used on the periodic table, it's AMU. We have 2 atoms of phosphate, and that's gonna, 2 atoms of phosphorus, and that's 30.97. Don't worry about the AMUs. I'm gonna explain that in just a moment. And I've got 8 times 16 AMUs. So if I was looking at one formula unit, I would be looking at atoms. And one formula unit would weigh 357.49 AMU. But since I'm talking about 1 mole of Fe3PO4, I have 3 moles of iron atoms, 2 moles of phosphorus atoms, and 8 moles of oxygen atoms. So the mass of 1 mole, is going to be 357.49 grams per 1 mole. Okay? So let's take a look at butane and calculate the molar mass of the whole molecule. If I had 1 mole of butane, how much would that be? I've got carbon, I've got 4 of those, and on the periodic table, it's 12.01, and for hydrogen, I've got 10 of those, 1.01 grams per mole, and I have 18.02 grams per, I'm thinking about water in my mind. And we have 58.14 grams per mole. So now that we've calculated the molar mass of a substance, we can use that information to help us solve these stoichiometric problems. So let's take a look at what we actually have, what type of problems we may end up with. You may be given a certain number of grams of a substance, and you need to find the number of moles that you have of that substance. Well, we have one set of conversion factors, and that would be the molar mass. So anytime we want to get from the grams of a substance to the moles of the substance, or vice versa, we must use a molar mass conversion. Okay? Next, if I want to go from moles of one substance to moles of another substance, such as if we were looking at a formula and we want to know how many moles of atoms is in a formula unit, is in a formula, or we want to compare moles to moles in a chemical reaction, then we will have to use a mole-to-mole ratio. And it all depends on what we're looking at. And we'll practice that, looking at the balanced equation and taking a look at within a compound. Now, the last type of problem you will be looking at is if I want to know how many particles of one substance is in a certain number of moles, or how many particles are in a certain number of moles. Here's where we will use Avogadro's conversion factor. Okay? So we will always use this roadmap, and before you begin, you want to know, where am I going in this roadmap? And it's always going to be grams to moles to grams. And we could talk about particles, they're on the outside, but we'll do some practice in the next video.